My name is Pete Whitney. I'm a solutions architect with GridGain. Been with GridGain for a touch over 2 years now, and I'm very pleased and honored to be able to present everything you hopefully ever want to know about transactions in Apache Ignite 2 and 3. In this presentation, we'll cover how, when, and why to use transactions. We'll cover configuration, use, and the implications of using transactions. And we'll cover the changes in transactions between Apache Ignite 2 and Apache Ignite 3. So let's get started. Transactions provide ACID capabilities. ACID is an acronym where the A in ACID stands for atomicity. All statements in a transaction are treated as a single unit. You either get the entire transaction or you get none. The C in ACID stands for consistency, where transactions update data in predictable ways. The I in ACID stands for isolation. Concurrent transactions are isolated from each other with controlled visibility. And finally, the D in ACID stands for durability, where data changes are preserved even in the event of a system failure. By default, the atomicity mode for a cache in Apache Ignite 2 is atomic. However, if you want to use transactions on a cache, the atomicity mode must be set to transactional. Be advised, though, the atomicity mode of transactional adds a performance overhead for any use of a cache. Therefore, only use transactions when necessary. Also be aware that the atomicity mode cannot be changed dynamically. To use transactions, you can't use an existing atomic cache. You'll have to recreate the cache with atomicity mode of transactional. To consider read consistency in Apache Ignite 2, you need to ensure that any caches that are transactional are also configured for strong read consistency. For strong read consistency, we'll really only focus on two core settings: the write synchronization mode and the read from backups property. If you have a read-heavy workload, we want to optimize the reads, but we may end up paying a small penalty for the writes. In this scenario, we would set the write synchronization mode to full sync. When Apache Ignite is set to full sync, an update to a cache row will update both the primary partition and all backups before that write is considered complete. And in this scenario, it's perfectly acceptable to set read from backups are true because we know that we're getting both the primary partitions and the backup partitions updated. So you'll either see the update or you won't see the update on both the primary and the backup partitions. By contrast, for a write-heavy workload, we want to optimize our writes, but we might pay a small penalty for reads. In this scenario, we would set our write synchronization mode to primary sync, where Apache Ignite will consider the update complete as soon as the primary partition has been updated. But in this scenario, we should not read from backups. We should force the system to identify the node that has the primary backup, the primary partition, and go to that node to read that data. I cannot recommend using transactions without strong read consistency. Here's an example XML configuration where we've set the atomicity mode to value to transactional, the write synchronization mode to primary sync, and the read from backups property to false. And we've named this template cache template trans1, one backup, write heavy. Gives us an idea of what to expect from this template. We also have one backup. We can use SQL and we can reference that template to create a cache that is a transactional cache. Do be aware that read from backups, it's not possible to set that in a with clause. So the only way to reference that property is with a template. Okay, so you'll actually need, if you want to create transactional caches or tables with SQL, you will need to create a template to be able to do that properly and to ensure that you have strong read consistency. in the Apache Ignite 2X series does not support transactions via the SQL interface. If we turn our focus to concurrency modes, a concurrency mode dictates when row locks are placed on entities involved in a transaction. For optimistic concurrency mode, locks are acquired prior to updating a row during a two-phase commit operation. Pessimistic concurrency mode, locks are acquired prior to reads and/or updates during a two-phase commit operation. From an isolation level perspective, optimistic transactions in the read committed mode, changes are gathered and applied during the two-phase commit operation. Data read can change on subsequent reads, but be aware no optimistic exception will be thrown. In repeatable read mode, it's similar to read committed, except the data read are cached on the originating node. This mode does not determine if an entry value has been modified, and no optimistic exception will be thrown. In serializable mode, Apache Ignite stores an entry version on first read and fails at commit time if Apache Ignite detects that an entry has been modified during the transaction. Interesting to note that it actually allows a change to occur in optimistic mode, but simply says, you know what, this transaction isn't successful because looks like something that you thought shouldn't have changed actually did change. Pessimistic transactions in read committed mode, the data is read without a lock and can later be reread and have different values. In repeatable read, a lock is acquired on initial read and all subsequent reads will see the same value. And in serializable mode, on the pessimistic side, this operates the same as repeatable read. Locks, an interesting discussion. In the transaction concurrency mode, as noted earlier, dictates when locks are acquired. But regardless of when locks are acquired, it's important to understand that locking inhibits the free access to data. Locking also slows concurrent access to data. With any locking scheme, locking requests for the same data acquired in different orders can result in deadlock transactions. To avoid deadlocks, ensure that locks are acquired in the same order for every transaction and every use case. Suffice it to say, this takes some organizational some good architects driving not just your use case development, but your entire company's development. Failure to handle locking concurrently will eventually lead to deadlock. Here's some example code that shows the use of transactions. In this instance, we're setting the transaction concurrency mode to optimistic and the transaction isolation mode to serializable. And we're creating a few entries and committing a transaction. Transaction implementation details in Apache Ignite 2. The transactional state for updated records are stored in a local transaction map until the changes are committed. If all transaction data elements are on one node, Apache Ignite switches to a single phase commit protocol. Multi-node transactions, by contrast, use a two-phase commit protocol. With native persistence, records are updated both in memory and on disk consistently. With external databases, Apache Ignite writes data to the external database before executing the commit operation to ensure consistency. From an overview perspective, Apache Ignite 2 has a wide variety of transaction options available. Using transactions has performance head for all activity. Apache Ignite 2 transactions are implemented using a two-phase commit protocol. Some Apache Ignite 2 transactions leverage locking mechanisms. Locking can impact concurrency and hence further slow cluster operations. Locking, when not implemented well, can lead to deadlock issues. And recent research indicates that the only viable transactions are serializable transactions. If we switch our focus now to Apache Ignite 3, Most exciting capability is that transactions are now supported in the SQL interface. Yes, it's finally come. All tables are transactional by default. Apache Ignite 3 has a reduced overhead for transactions compared to Ignite 2. Even if you do not start a transaction, an implicit one will be created by default. But understand that that implicit transaction is only going to be applied to a single row update, which is similar to having an atomic mode in Apache Ignite 2, except there is actually a transaction active for that row update. Tables have strong read consistency by default. A node that starts a transaction becomes the transaction coordinator. All nodes in a cluster should be synced to one time source, and the time drift for any node can never be larger than the setting for schema sync.max clock skew. Do take note that it would really not be wise to simply increase schema sync max clock skew to accommodate a drifting host clock. And the reason for this is the clock is part of the ensuring that all entities in a transaction are used in certain time series across all hosts, that is. Further details are transactions are implemented in Apache Ignite 3 using a multi-version concurrency control protocol, often referred to as MVCC. All read-write transactions acquire locks during the first read and/or write operation. All locks are held until the transaction is committed or rolled back. All read-write transactions are serializable. There are far fewer option variations related to transactions in Apache Ignite 3. Apache Ignite 3 uses a wait die deadlock prevention algorithm. This is a time-based solution for what do I do if I've detected deadlock. New concept called read-only transactions allows lock-free read-only access to data locked by other transactions. This, for example, could allow a request, such as to retrieve the current value from all of my accounts, to proceed uninhibited from other read-write transactional locks. It's an example of some SQL code using some transactions. It's just a few simple inserts, all wrapped inside of one transaction. These will all be entered, or they'll all fail. In summary, transactions support ACID capabilities in Apache Ignite 2 and Apache Ignite 3. Transactions reduce system-level concurrency. They should be used only as needed. Apache Ignite 2 allows finer-grained controls for optimistic, pessimistic, concurrency, and isolation. Apache Ignite 3 implements serializable transactions for all read-write transactions. Apache Ignite 3 transactions are supported via the SQL interface, and Apache Ignite 3 adds a non-locking read-only transaction capability. The final slide for this presentation is a reference to some links, some documentation links, both for Apache Ignite as well as GridGain 9. And thank you for attending. I hope you found this presentation valuable. I look forward to seeing if I can help you with any questions, and feel free to reach out to me on LinkedIn. Thanks for coming.